Welcome back and welcome to day 2 of the Ahead Cloud Summit. Again, my name is Tom Pullman, your virtual MC. Yesterday we focused on the applications. Today we focus on the foundations, the platform. And tomorrow we concentrate on day 2 operations, all with the goal of scaling the impact of public cloud on the enterprise. This morning we'll start off with Ahead Chief Architect Nick Collier on integrating a cloud operating model with infrastructure as code. Nick will then turn it over to Cooper Lutz to walk us through the concept of an automation hub using a demo of Ahead's own automation hub. We'll take a break and then pick it up with 2 more sessions later today, including the topic of security and how to address the needs of both your security team and your cloud team. And finally, we'll wrap up today with a really cool session featuring members of IT leadership at Xcel Energy, talking about the role of public cloud in their own digital transformation journey. So let's get going. I'll turn it over to Ahead's very own Nick Collier. Nick, take it away.
Thank you, Tom, and welcome everyone to this session where we're going to focus on integrating a cloud operating model with infrastructure as code. I've got a bit of a jam-packed agenda here to cover for you. Number one, we've done a lot of sessions recently on cloud operating model. A lot of customers have heard us talk about it. But really what we want to do here is do a quick review on that and then talk about why infrastructure as code is so important to it, and maybe some of the mistakes, customers are making today, and where you can, set yourself up on a good path. Then we will go into examples. There's a couple of demos here. We go a little bit deep in the weeds, and then come back out to show you how you enable your team, how you need to think about team collaboration. Most importantly, the thing I hope you get out of this session is just a mindset shift that people are having to undergo as they undertake this journey, as they're adopting cloud, whether that's on-premises or public clouds like Azure or AWS. So with that, let's sort of get stuck in with why we're here. Well, number one, cloud is not just a destination. It is absolutely an operating model. And we've got some stats here. Nearly 3/4 of remaining on-premises workloads could move to the public cloud in the next 5 years. And this is a really interesting statistic from some of our surveys of customers. 92% have cloud strategies that are inclusive of on-premises data centers and public cloud. So the future isn't on or off premises. It's public, private, and the edge. And I think it's very important to sort of set the stage. With that, though, complexity reigns and increases. This is the one thing I hear time and time again, particularly with customers that go multi-cloud. Hybrids typically where they start, they're extending the data center into, say, Azure, AWS, or Google Cloud Platform now. But what we're finding, this is one of the key metrics here, 66% of businesses say IT has become more complex compared to 2 years ago. And I think that's super relevant for this discussion. As you start to think about infrastructure as code, there's a mental shift that has to take place. And I think it's very important. As I've seen customers have more success, it's where they've really embraced infrastructure as code as part of their operating model. One last thing to sort of hit on from the business and the research side, you can see operational efficiency remains the most common objective for digital transformation. So you can see there, becoming more operationally efficient. 55% of respondents see that as a massive, element to tackle. And that really brings me on to, cloud operating model. And if you haven't seen some of our sessions before on our enterprise cloud operating model, we've essentially taken the AWS cloud adoption framework. We've got the Microsoft Azure cloud adoption framework, and we sort of slammed them together to make it easy for businesses to adopt both, clouds if they need to, so they don't have to, have all different frameworks for every cloud, as well as on premises. And we sort of aligned around these 12 pillars that we often zoom into with customers. And like I said before, we've covered that, in a session before. But what's really changed is you sort of look at these 12 pillars. At every area there's an opportunity to institute and introduce automation, very, very early on. And so I say then, well, why infrastructure as code? And when you think about it, this is what is basically happening today. You're in the cloud, but you're still doing this. We see this time and time again with customers. A developer is requesting infrastructure to work on a new application they're working on, or a team needs onboarding. Maybe they need Kubernetes infrastructure, maybe they need virtual machines, but they put these requests in and it feels archaic still. It feels like we're passing this piece of paper around between teams. And the key thing there is, a lot of customers have adopted Azure, adopted AWS, and maybe they're very good at networking and building services there. But in many cases, a lot of people are still doing it via the portals and clicking around and handing these requests off between teams. And so infrastructure as code, when you think about what is it, it's the management of infrastructure components using a descriptive model. So our goal is to eliminate those steps in passing that piece of paper around between teams, having people get more mature, deliver services at a much higher quality level. And that's across things like storage, networking, containers, app services, databases, in public cloud and on premises. And it's not limited to deploying just infrastructure as a service resources, also known as IaaS resources, in that private public cloud scenario. It's really about the entire infrastructure stack that we want to present back up there. So with that, you might be thinking, well, why now? Why is it so important to introduce infrastructure as code so early on? Well, for one, you're probably going to deal with a lot of cloud sprawl as you sort of, expand your cloud environment out in Azure or AWS or on premises. We've already dealt with virtual machine sprawl over time, and we don't want to introduce any more technical debt. So the later you start, the harder it basically is. And at the same time, you're marching towards this new operating model from the beginning where you're changing your business workflows around how you deploy services. It's a lot easier to just learn the code at the same time. And you'll see, some of that in the upcoming demo that I do for you. All of this comes back to three things though: speed, quality, and experience. We're trying to improve the speed at which we deliver services, improve the quality of those services that get delivered. And just for the application teams, the experience of them coming to IT and getting infrastructure in a much, quicker way, easy to absorb way through Automation Hub that you can learn more about throughout the summit, just improves the experience overall for them. So with that, let's talk about some of the approaches to infrastructure as code. Well, first of all, you've got the traditional approach that you might be aware of. We sort of submit a server request and automation then sort of takes over, and we submit these API calls out to all these different services. We often call this, serial orchestration, where we're basically connecting to other services. We do a task, make sure it completes, we pass variables from that task on to the next one. And you can see, we generate name, we get IP, we go to AD, we clone a virtual machine, and then perhaps we hand off to some sort of configuration management tool like Puppet, Chef, or Ansible, to configure the operating system of a VM. And then we sort of move over to do our change control. So you think of it, it's step by step by step by step, and all your automation is coded in that way. Well, with that mindset shift I've been talking about, this is where you have to sort of change your thinking when you sort of adopt more of a declarative infrastructure as code scenario. So the previous one, again, more serial, still code. You've probably got scripts and things that you run in. But now, what does it mean to sort of shift into that model? Well, with the IAC, infrastructure as code approach to IaaS, we essentially have this. We declare the end state for our resources. And what we do here in this example, you can see very basically, SQL Server, monitoring, rules, service registry, and Active Directory credentials. So we basically define all these, in something like Terraform, which I'm going to show you shortly. And then Terraform would go and do its apply. It would basically take that code and say, yep, what do I need to do with that? Okay, I've got to go and create a server, but then it's also going to create the monitoring rule, the service registry entry, and apply AD admin to the SQL server. So all the dependencies are automatically mapped. And then the plus part on top of that is the state is saved for day 2 utilization. So what does that mean then? We've deployed services with code. Great. We love the advantages here. But day 2 operations allow us to do this. When we want to change something, and again, this is the big difference. If you want to change something in the stack, you don't go back into the portal to change it. If you want to change your instance size or, add an additional node, you would change it in code. So you would go in here, and let's say you wanted to, adjust the monitoring rule for the SQL metric. You would go and, change that in the code. And then you would basically update that code. You would check it into your code repository, and then you would initiate again a plan and apply, where it looks at the current state of the objects that are provisioned, checks what's in the current state, the target state that you've now introduced, and then basically, makes the update to the settings that, you need to update. And well, the infrastructure needs to update because you've changed them as code. Now with that, you started to think about, okay, what is it? I've been talking about Terraform for a while. Well, Terraform is just a very, very easy language to do it in. You can do this natively in, say, Azure or AWS. AWS, it's Cloud Formation Templates. Microsoft Azure, that's ARM templates. So you can see on the left-hand side, this is an example of an ARM template, in the language that they write those in. And then you can see, the Terraform language on the right-hand side. So it's a lot easier, you can see, just by comparing the two code, pieces there to write it in Terraform. The plus also is that as you onboard additional cloud environments, you don't have to learn another language. Everything is basically in Terraform for you there. As we sort of look at the workspaces versus traditional, provisioning, infrastructure as code in a declarative model versus traditional provisioning, which was that first model, which I showed you kind of the flow going around. The key thing here also is it's an application-centric approach that you see on the left. Whether you're deploying one virtual machine, whether you're deploying multiple services, you essentially group those together, and that becomes your Terraform configuration and state for those services. In HashiCorp world, we call that a workspace, where we kind of group all that together. And I'll show you that in Terraform Cloud, which is the equivalent of Terraform Enterprise as well. And when you compare that to the procedural orchestrated approach, again, very serial. The app stack is not stored as code. Day 2 operations are a little bit more difficult. It's not to say that there aren't day 2 operations that we can automate and attach to virtual machines for powering off, recycling services, etc. But you don't have good audit tracking. Although it's easier to implement and, it's using your traditional on-premises methodology, it's just a little bit harder to manage at scale. And the key thing here, though, to also remember is it's not is it the first option on the left versus the option on the right? No, what we're seeing today is that customers are using both options. There are use cases where, hey, I do just want a form where I request a virtual machine. I want to choose my CPU memory. I don't really want to manage completely as code. My teams aren't ready to make that complete shift yet. So I do still want some automation and perhaps something like an automation hub, which I go into, select my services, and procedurally orchestrate them. It makes sense. On the flip side, perhaps I've got a modern application team that's delivering modern application architectures and adopting DevOps principles. I'm going to take a more application-centric approach to infrastructure as code and how I store that. So again, this is very, very important. Make sure you sort of understand the two, but don't make it a tug of war between both of them. With that, let's jump into the first of our demonstrations, where I'm just going to walk through some of the Terraform, code, what that looks like, and then what it looks like as you, get that into Terraform Cloud. So with that, I'm going to share my screen now. Okay, let's jump straight into the demo in the Azure portal here. And the first thing I want to show you is just some basic infrastructure as code. So I'm going to go in and look at a virtual machine. If I click in here, and I can see I have a virtual machine called CS 2020 VM1. And one of the things to note is you can, as a first step, if you look through here, scroll down and go to automation, export template. And a lot of the public cloud providers allow this, where you can go in here and you can actually see the code. This is the ARM template that deploys that particular, virtual machine. Now, this could have been deployed via the portal or via infrastructure as code. And the great thing is, in situations like this, Microsoft is basically making that code available for you, even if you deployed it from the portal. Now, to reuse that, you would obviously take elements of this and build your own infrastructure as code, your own ARM template. But this is one quick way to get started. The next way we really want to look at is, what does Terraform mean? Terraform, again, multiple clouds, multiple options there, but what does that code look like? So in this example, I've got two here. First of all, I've got CS 2020-Azure-storage, and I've got this file here, main.tf, and then I've got some other files in here which are variables, and these are basically what I'm using to log into my Azure subscription. And in this case, you can see here, I've got resource, Azure RM resource group, with a name Cloud Summit 2020. So this first Terraform file is going to create a resource, which is declared here, which is the resource group. And then it's also going to create another resource, which is a storage account. So this is a very basic example where I just want to create an Azure storage account in Microsoft Azure. And what I would basically do is I go through this process of planning and applying. So I'll basically open that folder. I will do a Terraform init to initialize, and then I will do a Terraform plan. And what it will basically do is look at the target infrastructure and determine what it needs to do to get it to the state. So if I scroll up here, you'll see it's going to add a couple of things, actually a number of things, but if we scroll up a little bit more, and here you can see it's going to add this resource group over here, and then it's going to add this storage account here. And then basically if I type in Terraform apply, this is locally, this is from my machine, going to connect to Azure through the variables I've got there and build out that storage account. So that's sort of step one, if you will. You can test your code locally, and then what you can do is you can put that code into GitHub. So for example, I can go to GitHub here, and I've basically got a couple of repositories, the Azure Linux VM one and the Azure Storage one. So this is the one we were looking at, Azure Storage, and those essentially are replicated up to GitHub. So if I go in here, I can see CS 2020-Azure-Linux VM. And if I scroll down, here is that storage one. And if I go into main.tf, you can see here is the same code that I have running on my machine. So nothing too complicated there. This is just code run on my machine that I've pushed up to GitHub. But the real key comes in is how do I start to share that and centrally manage this? And that's where Terraform Workspaces come in. So if I jump over to Terraform Workspaces, you can see here I'm in Terraform Cloud. I've got an organization called Cloud Summit 2020. I'm in here and I've got two workspaces. So I've got the storage one over here. If I click into there and click into the settings section, click version control, and you'll see it's mapped to that VCS repository, the CS 2020-Azure-Storage. And then the same thing I can do if I go back to my workspaces and click the Linux VM one here, you can see again, if I go to version control, that's connected to this GitHub repository. So let's take a look at that code. So right now we've got that storage account built in, so we'll take a look at that in a minute, but let's look at how we would do that centrally as well. So if I go into the code here and I click the Linux VM, click the mylinuxvm.tf, and you can see here I've got a whole bunch of additional code in here. In fact, if I scroll from the top all the way down, I still need to connect to my Azure provider. That could be AWS if you wanted to connect to AWS to place your resources, and then I've declared my Azure resources here. So again, I'm declaring a resource group. I'm going to tag that as well as Terraform demo. I'm going to create networks. I'm going to create subnets, public IPs, network security group rules, network interface, and if you scroll down here, the details for the virtual machine itself. This is the create virtual machine section, and this is where as code I type in the VM name. So maybe this is Cloud Summit VM 02 right now, so we'll use that. And then this is the size. This corresponds to the Azure virtual machine size. And again, I can do a plan and apply directly from here. Or what I can do is I can basically change this. Let's call this number 03. I will save this. I will check this code into GitHub. So we'll go over to GitHub here. We'll see that that's changed. So it's asking me if I want to commit that. So I'll go ahead and do that and push that up. And what's going to happen is it's going to push that up, and Terraform is watching that repository. So if I go over to Terraform again, go to the workspace, go to the Linux VM, and you can see it's already planning the deployment there. In fact, if I click in here and click into this first one, you can see just like it did locally, it's basically checking the target. It's running a plan to see what it needs to do. And you can see it's almost completed there already. While that's still going on, if I look at the other one here in Azure, if I go back to the home screen and go back to all of our resources, so open up our resource groups, you can see we had that example VM first of all, but now we've got this new resource group, Cloud Summit 2020, and that's got that storage account that we created. Now remember, that one was created locally from my machine, just pushing directly to Azure. If I look at this run that's going on, we can now see that the plan has basically finished here. And the cost estimation is also now running. This is one of the great features. In addition to just, is the target state meeting what I've defined as code? Now I can start to say, well, how much is this going to cost to run? And in fact, I can build additional policies on top of this. I could say, hey, if the cost exceeds $100 a month, this particular user who's logged into Terraform running this cannot deploy that. And I can expand these out. It'll only show, as you can see, the core sort of resources that really have an impact on cost there. Things like storage account, a little bit hard to do because it depends how much the user's actually using. But HashiCorp continues to expand on this, continues to add additional cost estimation resources in here, so you can see what something's going to cost before it deploys. So in this case, this basic Linux virtual machine is going to cost $52.56 per month. Now with that said, I can now confirm and apply directly from here. Now I've got audit tracking again. I can make a comment, I'll just call this demo for Cloud Summit. That's why I'm doing this. Click confirm plan, and that is now going to go ahead and apply that. Now you might be wondering about the variables. Well, those are stored in Terraform Cloud or Terraform Enterprise here for us. So again, I've got those variables declared in terms of I want to connect to Azure, but my subscription ID and everything is stored here. And you'll see more of that in a little bit later on in another demo as well. But you can see, yeah, this is going about actually creating everything in Microsoft Azure now as well. So if we flip back over to Microsoft Azure and I click in here and I click our resource groups and refresh, we should see, yep, there it is, Cloud Summit 2020-Linux VM. And we can see resources starting to get populated in here. In fact, if we refresh a little while, we'll start to see, that virtual machine appear here as well. And there we go. We can see Cloud Summit VM03 is there. If we go back to Terraform, we can see it's still creating. Not everything's completed yet. So once it's verified, all those resources are completely up and running in Azure, then it will tell us it's complete. Now I can also go in here and do destroys as well. So once this is completed, I can go up here, I can click settings, I can go to destruction and deletion, and you can see here I can queue a destroy plan. And I can also delete this workspace as well when I've completed. And if I also look at the settings for that version control piece here, I can see our automatic run trigger. And so the reason again that automatically ran was because it's connected to the GitHub repo, saw the change as I committed it, and then triggered the run directly. And that's, just part of this whole process, part of this mental shift of, hey, if I want to make a change now, I would go back into Visual Studio Code. If I want to change the instance size, I would change it here. If I want to change the name of that machine, I would change it here. All the resources, you've got to get used to this concept of changing the infrastructure as code, and that's how your day two operations are impacted. So with that, we'll jump back over to our slides now. And we should be back in slides here. Here we go. So we sort of ran through that, the basic Terraform recipe, deployment, and some of the cost management features that are ultimately, available to you there. So what about managing this at scale? What are some of the tool sets I need to be thinking about? What are some of the architectures I need to think about at scale to really do this effectively? There's a lot of tools in this space, obviously. Everything from image management. A lot of people use HashiCorp Packer. It's a free tool that's out there for creating the images for your virtual machines and baking in whatever components you need to there. For provisioning, you've got AWS CloudFormation. Google's got tools for that. Azure's got the ARM templates, got vRealize automation on premises. We still see a lot of that. And then obviously now we're seeing a big rise in Terraform in the industry as a whole, which is, the tool I was just showing you there. Then in addition, you've also got configuration management tools. Now they differ a little bit. The Terraform is going to still do configuration management, but it's ultimately going to do it on your infrastructure outside of, say, an operating system. When you want to run sort of software installs and other things on top, you essentially want to use tools like Ansible, Puppet, Chef, tools like that. Ansible is also great. We see a lot of, adoption of Ansible as people are using it to run playbooks and other things, some of those day two operations that aren't really around changing the infrastructure as code, maybe just need to recycle services or something on a machine. Those are things that Ansible, does extremely well. So lots of tools to choose from. So first thing at scale is making sure you've got the right tool for the job. Best of breed is definitely the answer here. And that leads us into the sort of modern automation architecture that we see a lot of customers, ultimately adopt today. First of all, it's about decoupling and knowing what does which task. For example, we use ServiceNow heavily. Again, you're going to see that in the next session that focuses on Automation Hub, where users can come in and, do requests for all sorts of services. And I will show you, one more demo where we sort of request our workspaces as a service momentarily. We've also got developers that come in on the bottom left here, and they ultimately want to use their CI/CD tools. Maybe it's Jenkins, maybe it's Azure DevOps. Their persona is more akin to that. They've got workflows that they want to run through, and they need to consume these stacks more from an API. So we think of like a tech orchestrator. With ServiceNow, we often use something called Integration Hub, when we're sort of exiting ServiceNow. And we basically go over to this tech orchestrator that's in the middle here. And this is where we might use a combination of technical orchestration orchestrators. I was showing you Terraform. Terraform does a number of tasks. On premises, we see a lot of vRealize automation, vRealize orchestrator, and certainly the CI/CD tools can be used in this space as well. But then we see a bit of a difference for on-premises. We see more adoption in, say, the VMware space, vRealize automation, and Terraform. In the public cloud, people are often using, say, Azure ARM templates, CloudFormation, but then really looking at something like Terraform early on because of those multi-cloud capabilities. And then we already discussed the, OS configuration management. This architecture is very flexible because it helps us, again, to choose the right tool for the job. We know how they connect together. Everything's decoupled in a simple way. It's much easier to adopt. If we want to make changes on the OS config, we can do that there. If we want to make changes to our Azure AWS config, we can do it very easily in something like Terraform. And if we want to provide a portal, we can do that very easily on top of ServiceNow. So this works very well as a holistic framework. The other key thing is about building Lego bricks of automation. And you'll do this, in something like Terraform and other tools. We ultimately have different use cases in different scenarios. Perhaps, initially you're building a VM, you're offering up storage accounts. Later on, perhaps you want to offer up load balancing capability, different login systems you connect to. The key here is having the provisioners and the way to connect to these different systems. And so you sort of build up over time this library of Lego bricks. The key thing is to look at your app portfolio first of all, and say, what is it that I really need, to offer up to the business? What's going to help accelerate them? And then you go about building those different components. As you have all those components and you assemble them into services, it becomes around managing that sprawl and looking at those services as part of your cloud operating model. It's not just about the infrastructure as code. It's about looking at services that you're going to absorb from, say, Azure and saying, yep, I'm going to adopt, Azure App Service, for example. Perhaps I want to adopt some services, S3 storage from AWS, and I want to add that to my portfolio. And I want to put some good, clean governance around that to make sure people are consuming it in the way that I want to. Perhaps I'm offering, virtual machines up from VMware and other services. So over time, you're sort of building out this catalog of modules that you sort of start to assemble, into standard stacks that you can offer up. The next thing then is to think about, again, that consumption model. How do my users want to consume those services? In some cases, it's going to be, yep, I want to put it in a, service catalog. In other cases, they want to consume it more via an API. Maybe they want to hit the Terraform API, provision something, all sorts of different ways, things can be done. And this sort of brings us back to workspaces as a service. The dynamics changed here. When somebody's coming in and saying, yep, I want to request a virtual machine, they're going into that catalog, they're filling out a form and requesting that. But what happens when they want to engage with you as your IT team or in your DevOps culture that you've built, and you want to now offer up, say, a workspace as a service with some pre-created code? Well, let me show you that in the next demo that we have here. So I'm going to share my screen again here and share there. And looks like we're sharing. So next thing I'm going to do is head over to ServiceNow. So if I sort of refresh my screen here, what you're looking at is an instance of ServiceNow. And essentially we've put our automation hub framework on top of that. And I can go into the catalog itself, go in here and select DevOps services. And I can click here, Terraform Workspace. So this is going to allow me to do a couple of things. It's going to create the following: a GitHub repo, a Terraform template for that Linux virtual machine deploy. In fact, I'll make this a little bit bigger. A Terraform workspace with variables. And that Terraform workspace is going to be linked to the GitHub repo. So here we go. I'll put in my name. I'll be the requester. So this is perhaps an app team coming in and saying, yep, I need I want to start with that Linux VM template, and, I need a new workspace, and we'll call it Cloud Summit Test 1, which we'll call it 2020. We'll call the name of the GitHub repo Cloud Summit Test 20 as well. Let me just double check. I don't have repos called that. No, I think we're good. And we'll click submit here. And that's basically going to go ahead and create that workspace and that GitHub repo for me. And I can monitor my requests here in ServiceNow. But if I go over to GitHub first of all, and I click in here and go to repositories, we should see, first of all, Cloud Summit Test 2020, and then we'll see that Linux VM Terraform code. That's all there ready to go. If I go over to Terraform now, in fact, if I refresh already, you can see there Cloud Summit Test 2020 is already there. And if I click into it and actually click the variable section here, I think this is the most important piece. It's already put in the client secret, client ID, tenant ID, and subscription ID to connect to the Azure environment. So perhaps you want them to target different, subscriptions. You would make sure that the appropriate variables, get added there. And then just like normal, I can queue my plan up and it's going to go ahead and deploy that workload into Azure. So, no different than the other one here, except I've given them some sample code to get on with. And this is all about increasing that developer productivity, arming them with Terraform very early on from the beginning. Yep, you're looking to build a VM or a stack, maybe it's multiple virtual machines, maybe it's database services, maybe it's Azure App Services plus SQL, maybe it's, RDS services in AWS, maybe it's on-premises services. This is where you can bring it back. You can offer multiple modules, multiple configurations, and essentially you're just providing that Terraform code to them, providing them an environment to connect to, and then you're getting them into the mindset of, hey, if I want to change, the infrastructure, if that's not exactly what I wanted, but that's what I wanted to start with, working with the IT operators now, can work together with the development team, to get them the right set of infrastructure, and then you basically have audit capability as well. So I'm going to stop sharing again. Yeah, hopefully that's pretty clear, and you'll learn again more about Automation Hub, coming up. But with that, let me jump onto one last slide as you think about this. What does it mean to do change control as well? Because you've got approvals, and we use the sort of that serial. I'm going to go and write a change control, and we can absolutely link into it. But I would say get into the mindset here. If this is your workspace in the middle, and that's where we've got our Terraform code that's automated. In this example, maybe some Azure infrastructure. Who are the approvers going to be? And how much auditing capability do I have now, because everything is stored as code. So people can go into GitHub, they can see those changes. You've got human approval, but not execution. That's all getting taken care of through the Terraform environment that you saw there. And one thing to think about is change control now my pull request in the scenario? And that's where you decide who approves the pull request. When you take a concept from development and move that code all the way through to production, and obviously you'll be targeting a different subscription there. There's no reason for a human to actually go and go into the portal and initiate those deploys. If it worked in development, worked in stage, it's going to work all the way through into production. Can you hear me, Cooper?
Hello. I can hear you.
All right. Hey, everyone. All right. We've got Cooper and I have got to work on our virtual transitions here in this new crazy world we're in. So, but thanks everyone for bearing through us as we kind of navigate this. And excited to take some questions. We got a whole bunch here, Cooper, in the chat. So let me kind of scroll back through here. So I think the first one, I don't know how we sort of prompt these as answered, but yeah. So Faisal Afzal asks, can we leverage Ansible infrastructure instead of using Terraform? I think that came up during my session there. So yeah, absolutely. I think you probably saw it, probably got answered in Cooper's session that sort of followed mine. But essentially, yeah, I mean, Ansible we definitely see as a piece of the architecture. Maybe it fulfills the IaaS OS configuration management piece. That's certainly possible. Or it can be used for some of the data operations, can be used for some of the infrastructure builds. Really depends. I think you asked in your second question, around the declarative model. You sort of have to define, what you get with Terraform is your entire infrastructure is stored as code. So we have like full state management basically there. And then we go and we change the code, and Terraform can hand off smoothly to Ansible to do certain things that it's better at. So I think that's just a case of, as you saw with Cooper in the architecture, that's a best of breed scenario there, where we would, absolutely advocate for both options. I don't see any concerns there. Cooper, do you want to add anything to that?
I know I've ran into this a couple times, because your Ansible can actually deploy and handle some provisioning of your Azure resources, for instance. And I know they're introducing the concept of like drift detection and things as well. Honestly, I don't see it used all that often, and it really comes down to kind of that concept of like, how am I ultimately going to manage my infrastructure as code? The Terraform, the Azure native, the AWS native, GCP native, whatever. All of those types of solutions, your process is essentially getting to that model of any change that I make is going to be made in code. I don't even necessarily need to worry about drift. If I get down to the concept of my only way of provisioning is via a service account, service principal, nobody can go in and actually modify a service without deploying infrastructure as code. I don't even need drift detection, in many of those cases. And it's really kind of that gray area in terms of like how much manual interaction or intervention do we want our administrators to actually have in this environment? That a lot of times is what I think drives our approach and the types of tools that we're putting in place to manage. Very long-winded answer. It is honestly very complex because we have all these different options, but that's generally the route that I want to ultimately get to. That is the perfect end state where I'm never actually logging into the portal and making a change in production against any of my services.
Yeah, I think the other thing I would add there is maybe understand the use cases first of all. So we would sort of map those out, decide, okay, what are we trying to provide up to our consumers of IT? And, certainly at Ahead, we do that with a lot of clients. So we just go through that exercise with you is an option, I think that, I think we answered your question there, but definitely reach out further, if there's other pieces you want to know around it. The next part there, so Tom Nagel. Hey, Tom, good to see you. Thanks for joining. The cost estimation policy, Terraform Cloud or Terraform Enterprise. Yeah, it's on both of those. So it's available. It's a licensed feature. So it's not, so it's part of the business program for Terraform Cloud and Terraform Enterprise. But yeah, it's available in both, whether you use the SaaS model or kind of the do-it-yourself model. I think there's another one related to my session, Cooper, is Integration Hub on the modern automation architecture. Yeah, I guess this applies to yours too. Slide the ServiceNow Integration Hub. Yeah, it absolutely is. When we exit ServiceNow, we sort of took a new, Cooper, myself, and a number of the ServiceNow team and the cloud teams that had. We really entered 2020 trying to think about, customers have been struggling with this gluing all these pieces together, all these different tools, and how do we ultimately come up with a much more simplified framework around this? And one of the key components of that was, when do I present something in ServiceNow? How do I make it easy to execute, from a catalog item there? And then how do I talk back to ServiceNow downstream from whether it's Terraform, ARM templates, VMware, Google, Azure, AWS, whatever it is. And so, yeah, we settled on Integration Hub. We thought it's a very, fantastic feature that ServiceNow added in recent years. And yeah, we use the spokes. We use pre-built spokes wherever possible, and we create custom spokes where those don't exist. And so it also allows us to very quickly accelerate and integrate, customer ServiceNow environments. So huge fans of, ServiceNow. Seems like they're on the same track. They want to simplify. They don't want to sort of own every component of the stack engine downstream, which makes sense. The cloud teams don't want ServiceNow in there. It creates too much work across both teams and handoffs and complexity. The goal is request it through ServiceNow, make that form intuitive, get the business logic in there, and let the technical teams do their automation tasks downstream, whether it's Puppet, Chef, Ansible, Terraform, ARM, AWS, CloudFormation, Yeah, so I think that makes sense. Could you want to take the next one? Yeah, what is the best way to use infrastructure as code with Azure when you have a non-public on-prem GitHub Enterprise instance? Do you want me to take it?
There's really nothing that's going to prevent you from utilizing your infrastructure as code with a private, or on-prem version of GitHub. I think some of the things that you'll see is just the concept of how you're handling pipelining. And there's a lot of different options, really. So if I think about from a Terraform perspective, I can utilize Terraform Enterprise, where it's going to have that on-premises hosted version of the Terraform orchestration to actually connect out to my on-prem GitHub Enterprise. No issues there whatsoever. Still same integrations. It's just not publicly hosted. And then there's also, from a Jenkins perspective, Jenkins X, I have the ability to host my own. Azure DevOps even has actually Azure DevOps and GitHub, given that they're kind of blending the two, I think as we're all starting to see, they both have the concept of a hosted runtime worker, or I think their names kind of differ, but it's essentially the hosted orchestration that I can run my own VM privately in my own infrastructure. So from like a pipelining perspective, to actually orchestrate my infrastructure as code, no problem. From storing my infrastructure as code, no problem whatsoever. It's a little bit different than you would normally approach just via the public version of GitHub, but you shouldn't have any problems whatsoever, Stephen.
Yeah, no issues. Okay. Next question. Will the slides from the presentation be available after the session for download? So we will check in with our marketing gurus here and see how they're making that available. Otherwise, if you're already an Ahead customer, just reach out to your client director. We absolutely can get those to you. We can PDF them up and absolutely share them. I think they tell the story really well, and we've built a lot of that with customers over time. So I think I'm happy to share. Do you maintain, Scott Morse, do you maintain the Stack engine? And if so, where is that hosted? You want to take that one, Cooper?
Go for it.
We take that. Yeah. So I think you're referring to there is the elements on the right from Automation Hub. So they're still the tools you use. So it's still going to be Terraform. It's still going to be things like vRealize Orchestrator, vRealize Automation for on-prem. The Stack engine isn't a product. It's a choice of product that's out there. It's really the concept of how do you build the modules, assemble the stacks, and present them. But it's the same tools you're probably using today. And that was our goal as we also built this out. You've probably got the tools already in a lot of cases. We just need to assemble them in the right way. And so then you have a process of your team builds, develops the code, tests it, releases it, out into the wild. So, I think, when you say where's it hosted, it's going to be a combination of public and on-prem locations, but it's more about, let's look at your use case. Let's pick the right stack engine of tools. Let's pick the right technical orchestrator for your scenario. Let's decide if you present it into ServiceNow. Let's decide if you've got Jenkins or Azure DevOps. And we sort of glue them all together, give you a framework every time you want to create a new service. It's very easy to do so. Donald Smith, of the infrastructure stacks, what do you find to be the most difficult to automate provisioning? I think we'll both have a stab at this one. So I'll let Cooper go first if he's got one, and then I'll sort of jump in with my example.
Quite honestly, I mean, if we look at some of the bigger players, and I assume by infrastructure stacks, you're kind of speaking to a lot of our private cloud and public cloud solutions. VMware, GCP, AWS, Azure, those are the kind of platforms that we work with primarily. Really, every single one of them is very much working toward making it simpler to automate the provisioning process. They're opening up APIs. They're developing more capabilities to allow you to automate their processes and work with their technologies. I have a hard time saying that I really find any of them challenging. It's not challenging from like, I don't want to pick on any one of them, but if I pick on GCP, for instance, that's probably fair because GCP as a whole is great for automating the provisioning process and working with their APIs. They're newer, so their features are being released. They're still being released. They're still being developed. They don't have as many of the platform as a service solutions as the other two big cloud providers. So that's the challenge usually, is keeping up with the pace of how they're releasing a new platform as a service or just a service on their platform as a whole. Keeping up with those, it usually takes a little bit of time. So they'll add, a new capability, a new service that I can now consume in GCP. It might take a month. It might take a couple weeks before I can actually integrate with that API have a Terraform module being developed. It's more that than challenge with actually interacting with the platforms themselves that I run into. And that's just kind of a given, quite honestly. They're all operating and innovating so quickly. It's just kind of a chicken and egg situation that we're trying to keep up with. Um, I don't I don't quite honestly work with many of the other kind of big cloud providers as well. But if we kind of think of like Oracle Cloud or Alibaba Cloud, a lot of them also have, from a Terraform perspective in particular, they have providers available. They're all being developed. They're all driven by not only HashiCorp but also the community. So they're trying to keep up with those public cloud providers. But again, you're going to see features or functionality released quicker with the big three cloud providers than you are with the other cloud providers. It's just kind of part of the way this whole thing works. But Nick, anything from your perspective?
Yeah, I would just say probably even I think Kuba hit a lot of the detail there. I would say at a very high level, it takes a lot longer to automate on-prem VM builds than it takes to automate public cloud services. I mean, it's just the nature of the beast, right? Public cloud, we deal with, to Cooper's point, there's Amazon, Microsoft, and Google keep their APIs up to date very well. We've obviously seen a lot of advancements with VMware and the SDDC constructs that have come in over the last 3 to 5 years here. But yeah, I would just say it still takes longer. I think public cloud has just been built around this model from the get-go. And on-prem, unless all of our tools and technologies are available from a common set like that, where something like Terraform can talk into it with all its provisioners, which is also growing. Hashi's investing significantly on-prem as well. I would say that's probably the short version there. The good thing is, once you say, hey, I want to do Kubernetes stack, or I want to do Azure App Service, Azure SQL, whatever these other pieces are, once you know how to do one of those things, just add in another one is quite easy to the stack. It's more just getting into the concept of adopting infrastructure as code, first of all, that I think is so important. In fact, I'm going to jump to a question because I think it kind of dovetails into that. So do you have any additional online resources to recommend for reviewing what the transition of operational responsibilities to this modern future of IT looks like? Yeah, so we certainly are continuing to push out content. So I would say keep an eye on the Think Ahead resources. So thinkahead.com, there's our sort of IO resources hub there where we put just tons of information out. There's videos and blog posts and things there. We do have a white paper coming out. I'd like to say it'll be out, in the next, 3 to 4 weeks, ideally. So that will get published, and watch social media for when that comes out. So I think that's critical. I think it's, have a conversation. We can talk through some of the stuff too with your client director, and we can obviously get conversations too. But yeah, we're trying to put as much out publicly. If Cooper and I spend a lot of time talking to customers about this. If there's one thing top of our mind is, how do teams transform into this new model? What does your CCOE look like? We've got some fantastic customers that have built their teams out and have gone through this transition that we learn from. We've seen customers struggle with it too. I think, that leads me to education, such a big piece of this, to the point of my session early on, adopting very, very early, integrating, if you immediately start your adoption of Azure and AWS and you're building everything in the portal versus immediately adopting infrastructure as code, you're going to find it a lot easier as you grow out your environment, that you've adopted the new mindset. So those are some of the things that I would say there. Cooper, you want to weigh in on that? I know you're passionate about this topic too. So, team transformation.
Yeah, no, I think shameless plug for some of the stuff that Nick and I have actually put out there. I think it's on our website about kind of our enterprise skills and cloud community of excellence concept. I mean, it's probably the bigger challenge in a lot of these scenarios is just transitioning how we think of ourselves as professionals in kind of this modern cloud, if you will, era. And really what it comes down to, the especially as we're talking about infrastructure as code. I mean, if I think about, as a developer, am I developing my infrastructure as code, or am I having, kind of the infrastructure team develop the infrastructure as code, and then the developers are handling the application code. We're all kind of coding at this point. We just have different versions of code, where some code is more focused on kind of the infrastructure side or the application side. It's very confusing, quite honestly. And I think that's the part that I kind of like, is because we start to all work together. We're working in common languages and formats, and we're all kind of working toward that same goal from an automation and a coding perspective. There's a lot of complexities. There's so much more that we could go into on that topic, because it is one of the more challenging things. But yeah, definitely like education, focusing, having common goals, common initiatives, even common languages that we're using from a infrastructure as code perspective. Those are really the big things that I would think about.
Yeah, I totally agree. Yeah, definitely love to talk to you more about it. We've only got just over 5 minutes left, so I'm going to try to go through these pretty quick. We've got a few pages of questions here I didn't realize, so let me try to get very quick answers, and hopefully we can follow up with you. How do we mix cloud and on-prem infrastructure for configuration, because builds will be different? That's where the best of breed comes in. So when we work with customers, we look at the stack engine. We say, this is the configuration for on-prem. This is the configuration for public cloud, where maybe in public cloud we're deploying an ARM template, or we're using Terraform or something. Maybe on-prem we're using vRealize automation as an example. That's where we sort of mix those options there. But ultimately, we do try to align things like the operating system, monitoring tools, patching, align as much as we can. And where it's different, just let the stack engine take care of that. You just build that into your automation, and it's okay if it's different, but align as much as possible so we don't have too much rework. Sanjeev Sharma, it appears a lot of coding behind the scene. How does this automation fit into low code? It's interesting, because I think we are seeing a rise in Power Apps, on the Microsoft side, a lot of these other low code platforms. vRealize Orchestrator is still a low code platform for on-prem, so we do use that pretty extensively for on-prem automation. Our goal is, if something exists and we can just drag and drop it in and connect it, we're going to do that first before we code anything. Us actually coding the REST API calls and things to services is a last resort. And we also do a lot of tagging now. We'll tag services and then have the operational tools just read the tag. So now you've only built one automation. You can tag the service with a whole bunch of metadata, and then the operation tools just pick up the metadata. We do that with patching. There can be like phases and groups for patch windows, and then you come in and you pick up the patch window, and it goes into, say, Azure Update Management, SCCM, Ansible, and Satellite. Work in some of those ways too. So that's there. I've got a follow on there. Let me just quickly skim through here. Ansible can be used as a bridging tool. We could follow up on that for sure. It's a pretty longer question we got time for. Sorry, go, Cooper. Did you find another one there?
Jim asks, when you are automating, how do you guarantee the architecture you are putting together is the best design for the cloud, not just doing lift and shift, but designing for a cost-efficient cloud design for the application you are running?
Yeah.
That's a good question. Overall, if I think about the way I'm building my infrastructure as code, let's pick an Azure SQL and an Azure web app, just standard app tier, database tier. When I'm going through and thinking about what does the code need to look like to build both of those services, I don't want to think about kind of the bare minimum to get it running. If you go out and look at I wish I could pull it up quickly, but if you go out and look at all of the parameters that I can plug in or configure just for an Azure web app, I think there's probably like 100 of them, if I'm not mistaken. There are so many different switches and things that I can ultimately build. And that comes down to, okay, let's take a step back and determine what is our standard configuration for an Azure web app. What are all of those switches that we need to rely on? And those now become things that are part of, if I'm using Terraform, that's part of my provider, that's part of my standard template that I'm building out. And that's not something that I'm allowing a developer or somebody else to actually modify let's call it the trying to pick on something like the backup policy of my Azure web app. I'm not allowing that to be changed. You have to follow that portion, but you can change the name all you want. You can change the deployment slots. You can change all of these different pieces. So mapping my standards to that infrastructure as code template and kind of going through more of that design effort, that's the way that we want to think about it. Hope that helps.
Yeah, totally agree. I think just to kind of tie off here, I'm just trying to find that question again. Yeah, I think the other thing is just planning up front. We do a lot of pricing calculator exercises too to help us like really think through the right architecture, because sometimes the fanciest shiny architecture might cost a lot more. And I think people need to understand those trade-offs and security and recovery trade-offs, that you're making as well. I've got time. I'm going to do one last one. Yeah, and apologies, we're sort of running on time here. Is the Ahead Automation Hub ran on an on-prem server? Does it talk to ServiceNow public API? Yeah, so again, it's a combination of tools, just to be clear. It's a framework. The ServiceNow component, though, is definitely, it's running on your ServiceNow environment that you have. And essentially, we push an update set in there. We're not doing any custom module. We do put like custom spokes into Integration Hub and some things. But our goal was we didn't want anything to break as you update ServiceNow throughout its lifecycle. So we're really using ServiceNow native for the front end portion of things. And then the downstream portion really depends on the tools. And with 5 seconds left, I'm going to wrap up here, and I guess just say thank you, everyone. Really appreciate it. Thanks, Cooper, and we'll work everyone on our virtual conferencing. And thank you so much, everyone. Have a good day.
Thank you.
All right, thank you, Cooper. Thank you, Nick. Just like we did yesterday, we're going to take a break now until 2 p.m. Eastern, at which time we'll hear from Stephen Aiello and Logan Wilcox of the Ahead security practice on the always lingering topic of cloud security. Then we're going to hear from Tim Peterson, CIO at a valued client of ours, Xcel Energy, and a few of his team members about their own cloud journey. So we'll see you back then.